Hi everyone, this is the review for the quiz on Unit 3, which includes unit circle, right triangle trig, and graphs of all six trig functions. You will have 6 questions, like these first 6, 12 questions altogether on the quiz. These questions on the unit circle really are not the unit circle, they're the unit circle spun many times. Not all of them, but some of them. So for this one, before you can evaluate sine plus cosine, you have to actually get the numbers here. So we have sine of pi, which is 0, cosine of pi, which is -1. Add those up. For number 2, you hold on to this 4, find the tangent of pi. Pi is flat, so the slope is 0. The sine of 2 pi is also 0, and so 0 plus 0. Now, for numbers that are larger than 1 rotation that you don't really know, just try to break it down. This is a fraction, obviously, so we can't really divide 121 over 4, but you can divide 120 over 4, and that's 30. So basically you're dealing with 30 and 1/4. Well, 30 puts you here at even. So we're really just in the first quadrant. So this is the same thing as the tangent of pi over 4. It's the exact same location. They are coterminal. The tangent of pi over 4 is +1. 11 pi over 3 is a little bit harder to find. You could count by pi over 3, but it's probably a better use of your time to know if this is 3 pi over 3, then all the way around is 6 pi over 3. If we double that, we get 12 pi over 3. We don't want to go that far, so we're basically right here. So we're in the 4th quadrant. All scholars take calculus, where the cosine is positive, and the cosine of pi over 3 is 1/2. So for 13 over 2, this is, 13 over 2 is 6.5 full rotations. So, or 6, and then, pi over 2, if you want to think about that. So we're going to go around 6 times, and then we're going to have pi over 2 left, because that's 1 left. And so if we go around 6 times, we're right here, and the pi over 2 means we're just right here. We're straight up. This is, of course, the point 0, 1, and the cotangent of that, well, I guess we don't need that point. Cotangents, the tangent is undefined, so the cotangent is 0. 5 pi, this is odd. Remember, this is even pi. Odd pi is over here on this side. And so this is the point -1, 0. Secant goes with cosine. The cosine of this number is -1. The reciprocal of -1 is -1. On your quiz, there'll be one question like number 7. Use your information to set up your right triangle, and then use Pythagorean theorem to find anything that's missing so that you can answer the question. So it tells us we're in quadrant 3. Triangle always goes up and down, never left and right. This is your angle right in here. We don't care what the angle measure is. Don't try to find it. You won't have a calculator anyway, so you won't be able to find it. The cotangent, I don't know, but I know the tangent's opposite over adjacent. So that means the cotangent is adjacent over opposite. So this is 9 and this is 10. So adjacent is 9, opposite is 10. Pythagorean theorem tells you that 81 plus 100 will equal, call it x squared, so 181. And the square root of 181. Now your hypotenuse will always be positive. In this quadrant, we have all scholars, so the tangent is positive, which means everything else is negative. We are looking for the cosecant. Cosecant goes with sine. Sine is opposite over hypotenuse, so we want hypotenuse over opposite. And because of its location, it's negative. So negative radical 181 over 10. There'll be one question like 8 and 9, where you're going to be asked to draw the parent function of either sine or cosine, but on a strange interval, not on a regular 0 to 2 pi interval. You can do this by just thinking through the pattern of the sine or the cosine, or how the unit circle would actually spin. So because we're going to go negative, I'm going to skip a bunch of numbers. We'll uneven there. And just like anything else we graph, well, parent functions, we count by 1/2 pi's. So there's -3, -3.5, -4, -4.5, and 5 pi. If you think about the unit circle, negative angles means we spin down. So here we are at 2 pi, here's 3 pi, here's negative 3 pi. That's 0. If you keep spinning in this direction, the next location is up 1. Then we're back to 0. Then we're down 1. Then we're back to 0. And that is the sine curve over that domain. Cosine is not the wheel. So we have 8 pi, 9 pi, 10 pi. But cosine still follows that same pattern of, and this is even on this side and this is odd on this side. So the cosine of anything even is 1. So at 8 pi it's 1, at 10 pi it's 1. Well, now you can see the pattern. If it starts and ends high, then halfway it's got to be low, and in the middle there, it's right on the zeros. You will have 4 graphs. You will be asked for the period, and then just draw your graph. Feel free to make any other notes that you might need. Every graph should be drawn for 1 period, except for tangent and cotangent should be drawn for 2. So for secant, the period is 2 pi over b. The b value is right next to the x, so this is 2 pi over 3. Amplitude on this, there isn't one, but you do need to label the ones because when you go to graph the cosine, you need to know where the ones are. So you make your 4 marks. 2 pi over 3 is the period. Also mark the halfway spot. We need to indicate where 1 and negative 1 are so that you can graph the cosine correctly. So we're going to graph the cosine. Starts high, ends high, halfway it's low, and in between it's on the zeros. You can connect these or not. That's your choice. The zeros become asymptotes for the secant. So please draw the asymptotes. And then you'll only have a half a parabola on each side and a full parabola in the middle. Now for tangent, we got some tricks for tangent. We mess with the period a lot on the tangent. First of all, the tangent, the period is pi over b. 1 pi over b. So this is going to be pi over 2. You want to double that, and that's how you want to mark your graph. So if we take that times 2, 1, 2, 3, 4, this is where pi is. This is where pi over 2 is. Tangent also gets graphed on the negative side. And to make one more thing, we're moving these zeros down 4. When you have the period is pi over 2, you want half of it on the negative side, half of it on the positive side. So pi over 2 times 1/2 is pi over 4. So this graph will start at negative pi over 4. This is where the first asymptote is, right at negative pi over 4. Then you have a 0, asymptote, 0, oops, that's an asymptote, sorry, here's the 0, asymptote. This is tangent, and you just draw in the curve. For number 12, we're dealing with sine. Sine is the one you know the best, most likely, maybe cosine, but those are the two that we're most familiar with. Period is 2 pi over b. The b here is 2 pi. Right? It's all the stuff in front of the x. So it's 2 pi over 2 pi. So the value for b is 1. We're also going to move this thing left 1. We're going to move it up 5. You have an amplitude of 3, and we have to reflect it. There's a lot going on here. We're going to have to really move this thing far to the left. We also have to really move it up quite a bit. So give yourself enough space up and enough space to the left. I'm just going to draw this right in the middle. So if the period's 1, we're moving it left 1. So basically we're moving the whole thing to the left. 1, 2, 3, 4, there's 1, there's 1/2. Here's where we're moving it up 5, and you have to be able to count up and down 3 from there. So there's 8. I'm going to draw my dotted line the whole length. Make sure you label. Oh, whoops, this is negative 1/2. This is -1, -1/2. Make sure you label the things to the left as well, especially when you have to add additional space to your graph. So make sure you are able to label that, whether you move it left or right. I'm going to start by just graphing the sine curve. It is a reflection. Sine has a 0 in the beginning, middle, and end. And since it's a reflection, it's going to go down first. So you have to count down from the dotted line, 3. You have to count up from the dotted line, 3. This is not the graph. This is the graph that I'm going to move now left one whole unit. So 1 unit on mine is 4 spaces. So this whole thing will move to the left 4 spaces. It does kind of end up right back on itself, but this is the part of the graph that needs to be drawn from -1 to 0. Cotangent, again, pi over b. b is 1, pi over 1, so just pi. And when you go to draw it, you double it. 1, 2, 3, 4, 2 pi, halfway. We are moving this thing up 1, so we do need to know where that 1 is. We're not moving it left or right at all, and the 2 out in front is not going to change anything. The first asymptote for cotangent is right on the 0. So we have it right there on the y-axis. Then we have a 0, up 1, then an asymptote, then a 0, and an asymptote. Cotangent would start up high on the left and then cross over. For cosecant, cosecant is sine. And period, of course, 2 pi over b. This one, we have just 2 pi, as a b is 1. But we're moving it left 4. It has an amplitude of 3. Now that amplitude does not really apply, not 4, pi over 4. The amplitude doesn't really apply to the cosecant, but we do have to graph it for the sine. So I'm moving it left, so I'm going to give myself some space to the left. Also have to plan for my amplitude of 3. 1, 2, 3, 4. Here's pi over 4. Oops, sorry, there's 2 pi. Pi over 2. Oh, so pi over 4 is only 1 space. We're only moving this 1 space to the left, so it's hardly moved to the left at all. Sine has a 0 in the beginning, middle, and end, and it goes up before it goes down. Now I haven't moved it left yet, so I'm going to move it left 1. Sine has a 0 to the left 1, and it's going to be right on the y-axis. This 0 is going to be at pi over 4. And so there is my sine graph that I'm going to turn into cosecant. The zeros become asymptotes. You should have an asymptote at negative pi over 4, positive pi over 4, and then again at 3 pi over 4. This thing goes up kind of right around the y-axis and down over here at pi over 2. And for the last one, our old friend cosine. The period is 2 pi over 1 over 1/4. So the period is 8 pi. We're going to also move this thing to the right 3 pi. So we have to go pretty far. We're also going to move this down 2, and we have an amplitude of 3. This is kind of a big graph, or could potentially be a big graph. So to the right 3 pi is a little bit hard to measure. So we are going to have to approximate this. Every line is 2 pi. So here's 10 pi, and here's 12 pi. Since I have to move this over here to where 11 is, I want to make sure I have 10 and 12 indicated. Also, we're moving this thing down 2. So we'll throw that new 0 line in there. And our amplitude is 3. So you have to be able to graph down to -5 and up to +1. No reflection. This is just regular cosine, so we won't have asymptotes. So maybe we just graph it all together. So cosine is supposed to start high. So we're going to move this thing to the right 3 pi. And it starts high, so it's going to start up here at 3 pi. It's going to end at 11 pi. The halfway should be at 7 pi, which is right here, down 5. And then your zeros in between there. And there's the cosine curve. So that's the whole quiz. You had one of each graph. On the quiz, there's only 4 graphs, so that's the main difference between this and the quiz. And I would imagine you're ready for it. Let me know if you have any questions. I'll be available during E&I on Monday if you need any extra help.